Okay, wonderful. All right, so we're gonna go over some problems today. So before I started, I had a students, as you know, we had the first quiz, and the quiz was about the differential equation, finding the transfer function of the differential equation, and then try to find the output when the input is given, all right? Like we have dc of t over dt plus 2c of t equals r of t, right? From here, we know that g of s is c of s over r of s. So we have sc of s plus 2c of s becomes r of s, or we can write it down over here as 1 is g of s is 1 over s plus 2. Correct? Now, we know that based on the definition, I want you to be careful about this, because this can be a question for some of you. Based on the definition, we know that c of s is r of s times g of s. Okay? So the Laplace transform of the output is the multiplication of Laplace transform input time g of s, the transfer function. Now, never do this. C of t is not equal to the multiplication of these two, all right? That equality will never hold. So it doesn't mean that you have transfer function, you can take the inverse Laplace of the transfer function and then multiply it to the input. So this is not correct, because there is a concept in the Laplace transform that we call it convolution. Then C of t is convolution of transfer function and input signal. And this is not multiplication. All right, keep this in mind. This is not multiplication. So I wanted to start with this because I don't want you to have some issue like this in your exam. Okay, so first I'm going to start with your question. So anyone have any question about any certain part of the course that you want me to solve, or if you have some question about the homework or anything? I do have a plan to work on some problems in differential and transfer function, and also in electrical circuits and operational amplifier. So, but before I start those problems, I'm gonna see which kind of the question you might have, or if there is anything in the course or in the homework that it is not clear, you want me to go over it, which can be important for the exam.
Someone asked a question in the comments.
So can you please, so whenever you have a question, because if I go over the comment there, I need to get back to my, to OneNote again. So it would be great if you have access to the microphone, just unmute your microphone, ask your question, and then mute it again. Okay, so let's go over homeworks. So which one, the operation amplifier or no, the circuit, which has the inductance and capacitor parallel to each other? So which circuit do you want me to solve? Because there are 4 different circuits. Okay, top right. Okay, so all right, so we have. So I'm gonna write all because the circuit in the homework part A, in the homework, they are all in the time domain. I'm gonna take them to the frequency domain because I don't want to redraw the circuit, all right? So here we'll have S over here. We'll have a cell with S here and the capacitor inductance resistor R. I will have S right here, 1 over S here, and then we'll have plus minus capital VI of S, right? Then we'll have capacitor 1 over S, and this is gonna be plus minus capital V of S, right? Is that correct? Okay, wonderful. All right, now, the way that you solve this kind of the problems, all right, is that the first step is to simplify the circuit. So how do we do the simplification? Is to find some impedances in the circuit that they are parallel or series, and then write the equivalent actually impedance. If you take a look at here, right, in this circuit, these 2 elements, they are parallel, right? Then I can write Z1 is S parallel 1 over S. This becomes S times 1 over S plus 1 over S, right? So then this becomes S over S squared plus 1. Now what will happen, I can get rid of this part, right? And then draw an impedance in a network. Its value is S over S squared plus 1. Now we do the circuit analysis. This is I1, this is I2, and this is I3, right? Now we want to write mesh equations, right? How do we write mesh equations? First, all elements connected, all the impedances connected to mesh number 1 becomes S plus S over S squared plus 1 times I1 minus, help me in the equation, minus the impedances common between mesh 1 and mesh 2.
S over S squared plus 1.
Perfect. It is S over S squared plus 1 I2 minus the impedance common between mesh 1 and mesh 3. Exactly. I3S equals to the voltage that we apply to mesh 1, which is V I of S. Now we go to the second mesh, becomes 1 plus 1 over S plus Let me put them in order. So common between mesh 1 and mesh 2 is negative s over s squared plus 1 I1 plus 1 plus 1 over s plus s over s squared plus 1 I2 minus what is the common elements between mesh 2 and 3? Just one, right?
Yeah.
Minus I3 equal to 0. So please mute your audio. I can hear something. So whenever you answer some questions, just please mute it. I don't want to get back to Zoom and then do it by myself. All right. So then we're gonna write for, this is for mesh 1, this is for mesh 2, and for mesh 3, we're gonna write it as negative s I1, negative I2 plus s plus s plus 1 I3 equals 0. Right? So now the goal is to find VOS. V is to find VO of s over VI of s. Okay? This is the transfer function. And we know that VO of s is 1 over s times I2 of s. Okay, so the rest of them, you have found the main equations, equation 1, 2, and 3. So you can do some, what you need to do is some mathematical calculation. So from this equation, you can find the I2 with respect to I1 and I3, okay? And then put it in the equation 2, and then find a relation between I1, between I3 and I1, put it in the first equation, and then write an equation with respect to I3, put it, find with respect to I1, and then find with respect to I2, all right? Or from this equation, you can write an equation with respect to I3 in terms of I1 and I2, all right? And then once you have found it, put it over here, then you can find I1 with respect to, in terms of I2, all right? Then you can replace I1 and I3 in the first equation and then find the transfer function. Once you have found the I2s with respect to VI of s, if you multiply that with 1 over s, you will get VO of s. So I don't want to spend, because the main equations are these 3 equations. And I may just ask you in the exam that write the mesh equations. But for your homework, I want you to do this practice and then solve some sets of equations that they have more than 2 unknown variables. Okay? So the main part in this example is to find a common or equivalent impedance in a circuit, put it in a circuit, and then do the analysis. Any question here?
Wait, Professor, so for an exam, would this be okay if we left it like this, or do you want us to go through and solve it?
No, I will, in the exam, I will ask you, okay, that, okay, now just find right mesh equations. You know, even in a class, we work on some problems, and I just told you that just write the mesh equations or just write the equations of motions. So we don't want to solve it, all right? So in the exam, I may just ask you, okay, just write the mesh equations. I don't want I will not ask you in the exam that go ahead and find and solve with 3 sets of equations. So this is not the goal, but my goal is that you can do the analysis and find a transfer function of electrical circuit. So if the circuit is just a 2x2, maybe you have a circuit. You may have a circuit that has only 2 meshes, 2 sets of equations. Then I will ask you, because that is something super simple. You could just simply write in a quantity with respect to other and then solve it. All right, but not for like some complex equation like this, because you don't have enough time to solve it. But at home, you have enough time, and I want you to try it, because this is going to be a good practice for the case that you have only 2 meshes, like what we have in the top left equation, the top left circuit, that you have only 2 meshes. All right, does it make sense?
Yes, and did you already do a previous equation? Can I see that real quick?
Sure. Which one?
The first one up top here that you said just did 2 meshes.
Oh, okay. Here is it.
I just joined on was all.
Okay. So this is homework 3 problem. This is the problem from homework 3. Top right. And this is the equivalent circuit in frequency domain. And so what we have found, we found the equivalent impedance between the inductance of 1 Henry and the capacitor of 1 farad, which is S, and 1/S. These are their corresponding impedance in the frequency domain. Then we have found the impedance, and we just took it out that circuit and put the impedance in the middle of the circuit, and then do the analysis based on the new and equivalent impedance in the circuit.
Thank you, Professor.
Sure. Okay. Any other question?
Could we do number 3 on the same homework, bottom left?
Bottom left. Okay. All right. So we have, this is a good question, and you may have some questions similar to this in your exam. 400K, 600K. All right, let me ask you this question. Which kind of the operational amplifier is this one?
This is non-inverse amplifier.
That is correct. Why?
Because VI connected to the positive terminal.
That is correct. Perfect. So you have to be careful about this. VO of T, and this is 110. Okay. Right? So all right, so we have the equation. We have this circuit, which this circuit has the non-inverting operational amplifier, right? So we do have non-inverting op amp. Now, you know that in non-inverting op amp, 2 impedances are so important. The first is what we see from here, which is Z1, okay, and the other one is the impedances that we have here as Z2, okay? So we need to find Z1 and Z2 and then try to find the transfer function. So the equation for transfer function is that VO of S over VI of S is Z1 plus Z2 over Z1, right? This is G of S. Now, so when we want to find the equivalent resistor, equivalent impedance of this circuit between two terminals, which is over here, which is what we have it as a VIT, between these 2 points, all right? So we have the same rule that we have for the resistors. And the rule is we have 2 components over here that they are parallel, okay? So therefore, this is a 600K parallel with 1/4 times 10 to the 6 S, all right? This is 1/CS. So that becomes 6 times 10 to the 5 times 0.25 times 10 to the 6 over 6 times 10 to the 5 plus 0.25 times 10 to the 6 over S. Okay? So this is what we have it as the parallel. If I put it as Z11, then I will find those values at this. Now Z1 we have a resistor 400K series with Z11. So Z1 becomes 4 times 10 to the 5 plus Z11. And if you do make some calculation or some simplification here, we'll have 10 to the 5 times 24S plus 25 over 6S plus 0.25. All right, so that is Z1 of S. So the same thing happens for Z2 of S, because Z2 of S has a part 600K, which is series with a combination of the parallel. So then Z2 of S becomes 6 times 10 to the 5 plus 11 times 10 to the 4 times 0.25 times 10 to the 6 over S over 11 times 10 to the 4 plus 0.25 times 10 to the 6 over S. So if I simplify this, we'll have 10 to the 5 times 66S plus 177.5 over 11S plus 25. So if we write the equation that G of S is Z1 plus Z2 over Z1. So, and then put everything together, we'll have 660 squared plus 2145S plus 1068.7 over 264 s squared plus 875s plus 625. All right. So again, this is just a question for example. I wanted you to work with these units. So if I give something similar to this in a homework in the exam, you will not have much involved, numbers like this, 10, 16. Okay, but again, this is just a homework, and you have enough time to do the calculation, this multiplication, and everything. So this is the practice for your exam, which it will have some numbers that you will be able to do it quickly. Right? So any other question? Okay, so if you don't have any question, I'm gonna go over the Laplace transform. And I'm fine. This was homework. This was from homework 3 as well. So this is example 1. So consider we have a transfer function. We have a differential equation. D squared c over dt squared plus 4 c of t equals dr of t over dt. So the goal is to find g of s, which is c of s over r of s, right? So the first step is to take the Laplace transform under 0 initial conditions, right? So what will happen, we will have c squared capital C of s plus 4 C of s. So keep this in mind. When you have C of t over here, right? So the Laplace transform, this becomes 4 of Laplace transform of C of t based on what we have as a linearity theorem. So it is not 4 over s. That will not be 4 over s times C of s. And it is not just 4 over s. It is 4 times C of s. If you see some number like plus 4 here alone, then the Laplace transform of that number becomes 4 over s. But if you have something multiplied with the number, a constant, you just need to put the main function in the frequency domain. And that becomes s r of s, right? Now, if I do the multiplication, if I do some simplification, factor out c of s, I will have s r of s, or transfer function becomes s over s squared plus 4. Okay, so one more point here. So I have seen some students that they wrote, when they have come up with the good and correct polynomials, right, which are multiplied to c of s and multiplied to r of s. But when they write g of s, they put it as s squared plus 4 over s. So they do not put the polynomials or binomials in the correct position in the transfer function. This is not correct. So g of s is c of s over r of s. So the polynomial over here is coefficient of c of s, and polynomial in the numerator is coefficient of r of s. So here coefficient of R of S is S. It comes to the numerator. Coefficients of C of S is S squared plus 4. It will go to the denominator. All right. So I don't want to see some, because the main part of this problem is to find this, and the rest of them is just simple math, right? So I don't want to miss it, because the next step, all right, I'm gonna find the output C of t when R of t is 2e to the negative 2t, all right? So if you put the g of s as this function, you will miss a point for the transfer function, and you will not get the current actually answer for the second part, all right? So make sure that if you have done, this is what I passed out the quizzes. This is what I wanted you to know, which part of the quizzes you missed and which part you need to do practice more. If you have some problems like this in putting the polynomial in numerator and denominator in a proper location, try to go back and see how many problems do we have solved, go back and check homework 2, and make sure that you will not get into the same problem. Because if you miss that part, you will definitely miss the second part as well. All right. So the next part is when we want to find the output, when we apply a specific input to the system. Now, I had multiple students, many students, that they, in this question that we had in the quiz, they put the right answer for the first part, okay? But they didn't do it they didn't do the correct procedure for the second part, all right? So again, the first part is the most important part. For the second part, we have an equation, important equation, that output is the multiplication of transfer function times Laplace transform of input, all right? Again, this is in the frequency domain and not in the time domain. You cannot take the inverse Laplace of the transfer function and then multiply it with the input signal in time domain and then get the output. This is not correct, and you will not get any point for that, all right? So what you need to do for this problem, you need to find R of S. Can anyone tell me what is R of S?
Is it 2 over s plus 2?
Don't you just leave it as squared plus?
Perfect. This is 2 over s plus 2, right? Which is correct, right? So then C of S is G of S. What is that? Is S over S squared plus 4 times R of S, 2 over S plus 2. Then C of S becomes 2S over S plus 2 times S squared plus 4. Okay, I had some student that they got C of S and they didn't do anything to find C of T. So we need to find, this is the output in the frequency domain. So we need to find the output in the time domain. So that is what we need to take inverse Laplace of C of S. All right, one more point. S squared plus 4, if you take a look at the roots, S squared becomes negative 4, or S becomes plus minus 2J. This is complex, and you can never write it down as s plus 2 times s minus 2. This is not correct, all right? Be careful. So you need to check if the roots are complex, if they are real, or if they are real and repeated. So since the roots are complex, we need to write it as s plus 2 k1 over s plus 2 plus k2s plus k3 over s squared plus 4, right? So we can find k1. What is the value of k1? You know that k1 is 2s over s squared plus 4 when s goes to -2. What is that value?
Is it -1/2?
Exactly, it's -1/2. I'm gonna take this out, put -1/2 here, right? So then if we do cross multiplication here, I'm gonna just write the equation. I don't want to go through all those detail. This becomes 2s equals -1/2 s squared plus 4, because the denominator are the same as the denominator are going to be the same as the denominator of c of s, and we just need to make the numerator equal in order to find k2 and k3 plus k2s plus k3 times s plus 2, right? So then 2s becomes -1/2 plus k2 times s squared plus 2k2 plus k3s plus 2k minus 2. 2k3 minus 2. All right. So this is what we can find for these equations. So this coefficient, because we don't have any s squared here in the left-hand side, this has to be 0. This coefficient has to be 2, and this coefficient has to be 0. All right. So we will have k2 minus 1/2 equal to 0. Therefore, k2 becomes 1/2. And from that equation, 2k3 minus 2 equal to 0. And k3 becomes 1. And if we put 2k2 plus k3, if we put k2 1/2 and k3 1, it becomes 2. Now, if I write c of s is -1/2 over s plus 2 plus 1/2s plus 1 over s squared plus 4. Correct?
How'd you choose the numbers for when we were going to solve that problem?
Which one can you say it again?
How did you get the 0, 2, and 0 there again?
Okay, that's a very good question. All right, so this part, this equation in the right hand side, it has to be equal to the left hand side, right?
Correct.
Correct. So in the left hand side, we don't have any coefficients or any term with respect to s squared. Therefore, in order to make the right hand side to not having s squared, this coefficient has to be 0. right? If I make K2 equal to half, then that part will be 0, which we don't have as a square in the left-hand side. Now, we have a polynomial with respect to s in the right-hand side. So in the left-hand side, we have a polynomial with respect to s. So therefore, they should have the same coefficient. The coefficient in the left-hand side is 2. So this results that 2k2 plus k3 has to be equal to number 2. And this is what we're going to make them equal. So, and the last term is a constant term. And if you take a look at the left-hand side, there is no constant term in the left-hand side. So therefore, this term, this constant term, has to be 0. All right? So that is what we will have three equations: negative half plus k2 0, 2k2 plus k3 equals to 2, and 2k3 minus 2 equals to 0. That make sense?
Not really. Sorry, my computer's slightly fizzy here. How did you get the 2 again? I heard not how you got the zeros there, but how'd you get the 2?
Okay.
S equals
So-
2 is just because the s's are equal to each other on both sides, you said?
So because I get it, this 2k2 plus k3 equal to 2 because the coefficients of the s in the left-hand side is 2. And in order to make these two polynomial, these two equations equal, they have to have the same coefficients. Otherwise, they will not be equal.
Got it. Thank you.
Did you get it? So yeah, here I can actually write it as 0s squared plus 2s plus 0, right? So, and these two coefficients is what we'll have it over here. Does it make sense, Donald?
Yep.
Okay, wonderful. All right, now we are in the situation that we need to split the second part to come up with some function in the time domain. So then C of s becomes negative half s plus 2 plus half times s over s squared plus 4, right? Plus 1 over s squared plus 4, right? So we know that this part, the inverse Laplace transform C of t of this part becomes negative half e to the negative 2t, right? So the second part becomes 1/2. What is that? What is the second part?
Cosine 2.
What is that?
1/2 cosine 2t.
That is correct. 1/2 cosine of 2t. And what is the third one? Can anyone tell me that? Perfect. It is 1/2 sine of 2t, right? Because sine of 2t requires we know that Laplace transform of sine of at is a over s squared plus a squared, right? So we have 4 over here, so we need to have a 2 in numerator. Therefore, I can write it as 1/2 times 2. That 2 over s squared plus 2 will give us the sine of 2t, and 1/2 comes to the coefficient. So we'll have 3 terms. We'll have negative half e to the negative 2t, 1/2 cosine of 2t, and 1/2 sine of 2t. And this is the output. That is the way that we find the output. This is a question with the complex. So I want you to do practice for the questions that they have real and distinct. We worked on some problems in the class, or they are real and repeated. Okay, So that is what we have. Any question?
Real and completed and real and complex? Is what we
Real.
have to worry about in the exam?
So three cases that we covered in the partial fraction expansion. So first, the roots are real and distinct. So we worked up many problems on that. Second, the rules are real and repeated. And third case is what we just solved a problem on that when we have complex roots, right? So this is what we have it. We'll have it. We may have one of these different, actually, different cases in the exam. Okay, so let me go to any question.
Yeah, I have a question.
Sure.
For the quiz, we were supposed to stop at the definition where hold on. We were supposed to stop where you gave us that one value for C of t, and then we were supposed to sub it into the equation that we got in step 1. And I understood that for the quiz, we were supposed to just do step 2 and that's it. Is that right?
All right, so let me tell you this. For the quiz, so you're given a first order differential equation, right?
Yes.
So then for the first part, step 1 is to find the transfer function. And you did that, right? Which is
Yes.
C of S over R of S. Now, step 2, you will have the same thing for your exam 1. Step 2 is to find C of t if R of t is some signal like U of t, e to the negative t, or sine of t, or whatever. Step 2 is to find the system response, right, when some specific input is given. So these two steps, they are connected because as we did over here, C of S is G of S times R of S. So what you need to do, you need to plug the G of S that you have found from the previous step, find R of S from here, and then plug it here to find C of S. So once you find C of S, you need to do partial fraction expansion, right?
Uh-huh.
And then find C of t as inverse Laplace transform of C of S, right? So this is what you need to do in order to get the correct answer. So you cannot multiply. Again, this is not something that you can multiply the function, take the inverse Laplace of G of t and have R of t and multiply them together, all right? Or
Okay.
I don't want you to put R of t in the differential equation and try to solve it in the time domain. We want to practice to solve everything in the frequency domain, all right? So
Okay.
this is the approach, this is the way, the procedure of how to solve this kind of problem. Now, let me tell you, it doesn't matter what is the order of the transfer function or of the differential equation. If it is a first order, second order, third order, you can just do the same thing. So even in the class, we worked on some problems that we had three different real and distinct roots in denominator or 4 roots in denominator. So it doesn't matter what is the order of differential equation. So you will come up with some functions over here. And then once you do the partial fraction expansion, you will come up with the simple fractions, right? And those simple fractions, you can go get back to the Laplace table and then find the corresponding function in the time domain. Does it make
Okay.
sense?
Yeah, it makes sense. I didn't know if once I found the given value, like if it's C of t equals a certain value, was I supposed to put it into C of s equals G of s R of s and just stop there, or continue? I didn't know about that.
Okay, yes, this is what you need to continue until you get the C of t. This is what we did over here. So, and that part of the problem, this is when the problem solved. Okay?
Okay.
So if you take a look at the example that we went through, that we found transfer function in the first step, all right? This is the transfer function in the first step. Then in the second step, we found R of s, we multiplied the R of s, this is R of s, and this is G of s. We multiplied them together, and we have found a polynomial, a fraction, a complex fraction for the C of s. But this is the output in the frequency domain. So we need to split it to a small fractions, because if you take a look at the table, you would never find any specific situation for this C of s. So therefore, we need to split it using partial fraction expansion to some terms. Now, we have complex rules. We put it as the terms of k2s plus k3 over s squared plus 4. So you may not have complex. You may have just simple roots. Then you will have like k2 over s plus 4 plus k3 over s plus 5 or whatever, any roots that you have, all right? Then you just need to find k1 and k2 and k3, come up with 3 different or 4 different fractions, get back to the table, and then find the corresponding terms in time domain, all right? So once you find C of t, you're done. You should not stop here, all right? If you do the C of s and stop here, you will miss half of the part of the calculation, because you haven't done the main part over here is to do the partial fraction expansion, find all these coefficients, and then do the calculation. So this is the main part, all right? So we worked on multiple problems, even if you take a look at the homeworks. So there are some problems that you already did using the finding the transfer function, or at least doing the inverse Laplace transform to find C of t.
Okay.
Okay, perfect. Any other question?
Hey, Professor,
Yes.
there's someone in the chat asking a question. They're wondering if you're going to be giving us the Laplace table in the exam.
I will do that, yes. I will give you the Laplace table in the exam. So don't worry about that part. Again, what I said in the class. Don't worry about what you will need. Just do these procedures, you know, make sure that you understand or understood how to do that, how to go through step 1 and step 2. So this is something that you cannot find it anywhere unless you solve a problem by yourself, right? So the Laplace table and Laplace theorem will never give you all these steps. So I will give you the Laplace table, but so I want you to know the steps that you go through the problems and solve it. All right, any other question? So let me go, I'm gonna go over another problem. So I have electric circuits. I think that it's about 4. This is example number 2. I have an electric circuit, VI of t. Well, 1 ohm here, 1 ohm here, 2 Henry here, and then 1 farad here. And then we want to find VO of t. Okay, so I'm gonna take everything to the frequency domain, but I don't want to redraw the circuit. This is gonna be VI of s. This will have it as 2s. This will have it as 1 over s, and we'll have here as VO of s. Okay, so then I'm gonna define 2 current, I1 and I2. All right, let me know what are sets of mesh equations. Okay, somebody give me, what is that?
V of S equals I resistor 1 plus resistor 2.
Okay,
Minus-
it becomes 2I1, that is correct, minus
2I of 1 as minus the I2.
that is correct. Minus I2 is VI of s. All right, so this is the first equation. So what is the second equation?
I of 2 times 2 of S plus 1 over S minus the I1 equals 0.
That is correct. Equals 0, right? So, and G of s is VO of s over VI of s, okay? And we know that VO of s is 1 over s times I2 of s. So if you have some question like this, so I want you to solve it because I1 here becomes s over 2s squared plus s plus 1 I2. So then I plug it over here to the first equation. Then I will have 2 times 2s squared plus s plus 1 over s. I2 minus I2 equals VI of s. Then if I take I2 out, I will have 4s squared plus 2s minus 2 minus s plus 2 minus s over s equals VI of s, right? So therefore, I2 of s becomes s times VI of s over 4s squared plus s plus 2, right? And we know that from here, I can say that I2 of s is s VO of s. I can write it as s VO of s is s VI of s over 4 s squared plus s plus 2. I can take out these two s, then G of s as VO of s over VI of s becomes 1 over 4s squared plus s plus 2. Right? So, and this is the way that we solve sets of differential equation. So you find one parameter with respect to other from one equation and then plug it to the other one. This is what, if I call equation 2 and this is equation 1, right? So you will see that I found I1 with respect to I2 from equation 2 and then plug it back to equation 1, all right? Then I found, if I plug it over here, this is what I have it as I1. So then we put it in equation 1, this becomes I2, we multiply these two inside the parentheses, 4s squared 2s plus 2 minus s over s becomes vi of s, then I2 of s becomes s times vi of s over 4s squared plus s plus 2, all right? So then from here, I2 of s is s times VO of s, correct? So I just replaced that with s times VO of s, took it out, cancel out the s in numerators, and then come up with the transfer function. Any question?
Where did the S VO of S come from again? Oh wait, never
So-
mind, I see it. Sorry.
Okay, if you take a look at here what we have a resistor, we have a capacitor, and the voltage across capacitor is V of S, right? In the frequency domain, and the current going to the capacitor is I2 of S. So this is 1 over S times the current of capacitor. This will give us V of S. So that is what we have found. This is a relation between VO of S and I2 of S. Now, if you multiply both sides of the equation by S, then I2 of S becomes S times VO of S. Does it make sense?
Yep.
Wonderful. Okay, any other question? Any other question? Okay, so let me go to another one. Okay, so we have question VI of t as 2R. I have 1 Henry over here and 2 ohm over here, and this is VO of t. Okay, so we want to find the transfer function G of S is VO of S over VI of S. Help me with this function. This is super easy, right? VI of S in the frequency domain 2. This becomes S 2. Can anyone help me? What should we do to solve it? Give me an idea. The simplest idea. What is the simplest way that we can solve this?
Nodal analysis?
Nodal analysis, we can do that, but easier way. There is another way which is easier.
Combine the.
We can, oh, okay, go ahead.
Vincent, what is that?
Combine the impedances. Combine the impedances. They're in parallel.
So we can do that. That is correct. And then what is next? What would be the next step?
Find by voltage division.
Perfect. That is correct. So we can do by, this is VI of S, this is 2, and I can find the equivalent impedance over here. If I write it ZQ, this becomes 2S over S plus 2. This becomes 2S over S plus 2. And the voltage across over here is VO of S. Therefore, we can simply write VO of S is 2S over S plus 2 over 2 plus 2S over S plus 2 times Vi of s, or transfer function is Vo of s over Vi of s becomes 2s over 4s plus 2, or s over 2s plus 1. Okay? So you can do the node analysis and then write down 2 nodes or 1 nodes V1 over here, and then find the node analysis for this as well. Okay, so that one also, if we do the nodal analysis, another approach is we'll have it, the current in this way becomes, and the voltage over here in this node is VO. So it's going to be VO minus VI over 2 plus VO over S plus VO over 2 equal to 0. Then from here, you can find VO over VI, okay? Which is going to be the same as what we did over here. So, but once you have some series or parallel circuits, you can simply do that over here. Use this is the voltage divider. Any question here? Okay, I'm gonna solve one more problem. Exam 3 or 4. What's that? 2. This is example number 3. This is example number 4. Number 4. Okay. So we have a circuit. Negative plus here. This is Vi of t. This is 100K. This is 1 microfarad. So then we'll have 200K. This is V of t. Okay, we have 2 microfarad. Right. So this is an operational amplifier. This is an op amp. Okay. The first question: which kind of op amp is it?
Inverting.
Perfect. It is inverting. Keep this in mind. If you don't recognize the correct configuration of op amp, you will get the wrong transfer function, right? Because you know that for this, what is the transfer function of the inverting transfer op amp?
Z2 over Z1.
Perfect. That is Z2 over Z1. And what is Z2? Is the equivalent impedance right there, and Z1 is the equivalent impedance right here. So therefore, Z1 becomes 1 times 10 to the 5 plus 1 over, this becomes 10 to the 6 over S, right? This is Z1, or we can write it down as 10 to the 5 times 1 plus 10 to the S, or 10 to the 5 times S plus 10 over S. Okay, so then Z2 is 1 times 10 to the 5 plus, we have 200K power with 2 microfarad, becomes 2 times 10 to the 5 times 10 to the 6 over 2s, right? Over 2 times 10 to the 5 plus 10 to the 6 over 2s. And we can simplify it. This to find, this becomes 10 to the 5 times 1 plus, that becomes 10. We'll have it at 10 over s, numerator over here. And denominator will have 2 plus 5 over s.
And there's a 2 in the numerator, I believe, right?
So I used, this is what, I took out 10 to the 5 over here, 10 to the 5 right there. Take it out. And then one of them, I took it over here, and 10 over 2 becomes 5, right? So that is what we'll have it. So, and you can do the calculation and make sure that it is correct. So we'll have 1 plus this 10, which is 2s plus 5, and then z2 eventually becomes 10 to the 5 times 2s plus 5 over 2s plus 15. Then g of s becomes negative 10 to the 5 times 2s plus 15 over 2s plus 5 over 10 to the 5 times s plus 10 over s. These two will cancel out. And g of s becomes s times 2s plus 15 over 2s plus 5 times s plus 10. Okay, so that is how we find the transfer function for the op-amp, inverting operational amplifier. So the most important part for me is to find the impedances Z1 and Z2, right? Like what we have over here, and like what we have over here, and then have a correct formula for the transfer function. So if you drive Z1 and Z2 correctly, and then put the equation for non-inverting operational amplifier, you will miss some point of the equation, of the problem. Okay, so any other question?
On the exams, is there going to be any integration?
No, we'll not have any integration in the exam, but we'll definitely have differential equations. So I'm not gonna ask you in the exam to find the transfer function or to find a Laplace transform of a function in time domain. I'm not gonna ask this kind of questions because we already have all those tables and everything. You can find transfer function, and you don't need to, or you can find the Laplace transform of any function in the frequency domain. So, but for me, it is important that you can solve some problem like this, all right? So as long as you know how these problems work, how you can solve some problems like this in operational amplifier, and when you have the circuit, you should be good for the exam. So these are three main parts of the exam that we covered in the class. So that's it for today. I'm gonna stop. If you don't have any question, I'm gonna stop recording. I will post the lecture on Canvas. Let's stop it.
Recording stopped.
And also the notes. So whenever it gets updated, I will put it on Canvas. So one thing, the due date of the homework 3 is midnight today. So tomorrow early morning, I will post the solutions. So make sure that you will not submit your homework solutions once the solutions are uploaded. If you have not done it yet, so I think that we already worked on 2 problems of the homework. We solved 2 of them and only 2 more left for you to do. So if you have not done it, go ahead and do it and submit it, because I want you to have the homework solutions in case that you want to go through that and then do some review or practice.
And this
So-
lecture, sorry, this recording is going to be on Zoom, right?
Yes, I will. Yeah, I will upload it on Canvas as well.